Hello, everyone. My name is Chao Duan, and I'm from Shenzhen Core Medical Technology Limited. Today, I'm bringing you the Corheart 6 left ventricle assistance device. So basically, our Corheart 6 LVAD is a blood pump which drives the blood from the left ventricle to the aorta, and the blood pump is powered by the external battery. So here's the feature of our device. As you can see, the diameter of our pump is 34 millimeters and the height of the pump is 26 millimeters with a weight of 90 grams. So comparing with nowadays benchmarker HXCORMED 3, our pump is more or less half of the size and half of the weight comparing to HXCORMED 3. Also, you can see here from the pump speed range, Corheart 6 is at 2,200 to 4,300 reps per minute range, which also gives up to 10 liters flow per minute. As you can see here in this RH&Q curve, this pump gives about 10 liters per minute flow at the rotation speed 4,200 to 4,300 with a pressure difference of 60 millimeters mercury to 70 millimeters mercury. Based on the experience in China, our patients usually maintain the rotation speed at 2,600 reps per minute to 3,400 reps per minute with the flow rate of 5 to 6 liters per minute. So usually the question would be how can you achieve the flow with a smaller pump like this? So our dedicated R&D team gives us the solutions with actual magnetic levitation, also with integral controller system. So you can see from here, with one set of coil, the electric magnetics here below can both magnetic levitate the rotor and control the speed of the rotor here. So by this design, I think our pumps have two great advantages. One is small size, which could be good for implantation and could be good for the recovery of the patient. And also, it can have a very low power consumption, which also first generates less heat to the human body, which probably gives a good hemocompatibility, and also lower power consumption. So we can try to use better battery solution. So here is the connections during the ICU and in home. So in operation room and in ICU, it has to connect with AC adapter and a monitor, which shows flow, speed, powers, and for physicians to evaluate. And in home, the patient only needs a controller with 2 batteries. So we have this advantage of lower power consumptions. So we try to develop a better configuration, lower weight for patients, which can provide them a better quality of life. With the controller size, more or less like a ping pong ball size, the battery weight is also optimized. We have 2 small batteries with controller with the back here is about 1 kilogram, which provides 17 hours battery life, which should be enough for daily use for the patient. And in case the patient wants to go travel for long distance, we have another configuration of 2 large batteries with controller with back to about 1.5 kilograms, which provides 34 hours battery life. So with less heat conducted to blood, we think our system could provide a good hemocompatibility. While in vitro test, our pump gives a very good result of IMIH, which is like 1/8 of the international standard. And with animal tests, we use 6 sheeps with 60 days. There's no pump thrombolysis, no thrombus related to the infractions of organs, no hemolysis detected. Last year in China, we have launched a study with 12 centers with 50 patients, follow up 3 months until 1 year. The purpose is assessing the safety and effectiveness of our Corheart. It's good, and this year in June, we gained our NMPA approval from this study. So the basic parameters here, all the patients enrolled is at the average age of 50 years old. Most of them are male. The BSA is 1.87. Most of them are with dilated myocardiopathy. And the LVEF is about 24. And LVEDD is about 77, 78. So this is the primary endpoint with 1 year follow-up. We have experienced 88% of the survival rate, and no pump replacement surgery occurred. But secondary, we have our patients have recovered from the NICA class 4 to NICA class 1 and 2. And also the patient shows a very positive 6-minute word test for after implantation. And follow-up, for now, we have ongoing support for 40 patients. We have 1 patient bridged to recovery. We have 3 patients bridged to transplantation. We have 6 patients expired during the follow-up. We have 1 patient, the longest patient on device is about 1.5 years, and the average support duration is about 290 days. Here's the result of the long-term follow-up for those events. We have 3 patients on bridge to transplantation. 1 is within 2 weeks, and 2 of them are with over 200 days following up. And now they are doing still okay. Yeah. And we have 1 patient with 300 days following up with explantation. The patient is recovered. And we have 6 following up deaths. 2 of them are dead within first week after implantation, and 2 of them are dead with 200 days following up. 2 of them are actually dead from the right heart failure with ineffective treatment. So we have the most attraction thing from our physicians usually are the driveline infection. With 1 year follow-up, we have 5 patients in persons driveline exit site infections with positive culture. For now, all of them are doing better after physician treatment. So based on the encouraging primary clinical results, we hope we will carry out an international European prospective multi-center study to assess 6 months of the improvement of survival, quality of life, and function status of our device. So that's pretty much of the information I would like to introduce about our. Thank you very much.